let's have a look at stars. What is a star? The objects that heat and light the planets in a system. A star is a ball of plasma held together by its own gravity. Nuclear reactions occur in stars, for example, hydrogen becoming helium. Energy from the nuclear reactions is released as electromagnetic radiation. Let's discuss some characteristics of stars. For example, distance, which is measured in light years. The distance which a ray of light would travel in 1 year, which is about 6 trillion miles, 186,000 miles per second. Let's talk about magnitude or brightness. Magnitude is a measure of brightness of celestial objects. Smaller values represent brighter objects than larger values. So get your brain and wrap it around. Smaller values, so we're talking about like negative numbers. So if you have a big negative number, that is a really, really bright object. Whereas one that has a magnitude of maybe 2 is a dimmer object. Now, apparent magnitude is how bright a star appears to be from Earth, whereas absolute magnitude, also known as luminosity, is how bright a star actually is. Let's also talk about temperature and color. The color of a star indicates the temperature of the star. Stars are classified by temperature, decreasing temperature from bright to dim. We classify them as Class O, Class B, Class A, Class F, Class G, Class K, and Class M. Since the stars are such great distances from Earth, their temperatures cannot be measured directly. Instead, astronomers carefully measure a star's color to determine its temperature. By measuring which types of light a star emits, astronomers can establish what the star is made of and how hot it is. Scientists have learned that stars come in a wide variety of colors and have a wide variety of properties. They use something called the Hertzsprung-Russell diagram to classify and measure the different temperature of the stars. As you can see, the sun is measured in the temperature degrees in Kelvin, and you can see it's yellow there, and it's right there at about 6,500 degrees Kelvin. Main sequence stars. Well, a major grouping of stars that forms a narrow band from the upper left to the lower right when plotted according to the luminosity and surface temperature on the Hertzsprung-Russell diagram. So let's take a look at that again. There's your Hertzsprung-Russell diagram, and the main sequence, you see that diagonally there? Those are your main sequence stars. Here's a chart that gives the types of stars and classifies them according to their temperature and therefore their color. So as you can notice, the temperature for Class O stars, we've got 20,000 to 60,000 degrees Kelvin. Those are the blue ones. Those are super, super hot. Our sun is a Class G star, and it's between 5,000 and 6,000 degrees Kelvin. So there are much, much hotter stars out there besides our sun. Let's quickly look over the life cycle of stars. Stars begin their lives as clouds of dust and gas, called nebula. Gravity may cause the nebula to contract. Matter in the gas cloud will begin to condense into a dense region called a protostar. A protostar continues to condense and it heats up. Eventually, it reaches a critical mass and nuclear fusion begins. The main sequence phase of the star then begins, and most of its life is in this phase. The lifespan of a star depends on its size. Very large, massive stars burn their fuel much faster than smaller stars. Their main sequence may last only a few 100,000 years, which doesn't sound like too short of a time in our lifetime, but for a star, that's a short amount of time. Smaller stars will live on for billions of years because they burn their fuel much more slowly. Eventually, the star's fuel will begin to run out, though. It will expand into what is known as a red giant, and massive stars will become red supergiants. This phase will last until the star exhausts its remaining fuel, and at this point, the star will collapse. Most average stars will blow away their outer atmospheres to form a planetary nebula. Their cores will remain behind and burn as a white dwarf until they cool down. What will be left is a dark ball of matter known as a black dwarf. If the star is massive enough, the collapse will trigger a violent explosion known as a supernova. If the remaining mass of the star is about 1.4 times that of our Sun, the core is unable to support itself and it will collapse further to become what's called a neutron star. The matter inside the star will be compressed so tightly that its atoms are compacted into a dense shell of neutrons. If the remaining mass of the star is more than about 3 times that of the Sun, it will collapse so completely that it will literally disappear from the universe. What is left behind is an intense region of gravity called a black hole. So here's one last look at the life cycle of stars.